Okay. So to find the zeros means what?
Find the x-intercept.
Find the x-intercept. Solve for x. Yes. All synonyms. But when you're talking about meaning, not just words. But yes. All those things mean the same thing. So I'm going to factor to find those zeros or x-intercepts. 2x times x is 2x squared. What times what is negative 15? God bless you. Negative 5 and 3, or negative 3 and positive 5. I think I'm going to do that. I'm going to put my negative 3 on the outside and my positive 5 on the inside. How do you know if you did it right? Check the rainbow. Really important to check the rainbow. 2x times negative 3 is negative 6x, and 5 times x is 5x, and that's where that middle term comes from. So now if I'm going to set each bubble equal to 0, what does x equal? Negative 5 over 2 and 3. Okay. So to graph that, I can just 1, 2, 3. Here's negative 5 over 2. And 1, 2, 3. Is it an up or down parabola?
It's
No. Up parabola. Yeah. What's the y-intercept? Negative 15. Very good. 0, negative 15. Very good. Okay. Okay. So today we are writing equations of polynomials. Now this is an equation of a polynomial. It happens to also be quadratic. But what we're doing today is saying, hey, if I know these solutions, can I work backwards? Yes. If I know the solutions for x, can I go backwards and put them back in bubble form?
Yes.
Yes. And then if I have them in bubbles, can I multiply them together to write the polynomial? Yes. That's what we're doing.
Wow.
Okay? Okay. So, example 1. Write a polynomial function that has real coefficients. Real coefficients, as opposed to imaginary ones. Real coefficients using the given zeros. Okay, so they've given me zeros, which means x equals 1 was a 0, a solution. X equals negative 4 was a solution. And x equals 5 was a solution. And so if I know that those are the zeros, again, just like I said, we want to convert those back into bubble form. So if x equals 1, what bubble did that come from? X minus 1. Very good. It's like just taking the 1 and pushing it over to the same side. So we'd have to subtract the 1. Okay. If we know x equals negative 4, what bubble did that come from?
X plus 4.
And x minus 5 for that bubble. Very good. Guess what? That's
it?
no.
Oh.
No. That was the easy part. So now you actually need to multiply everything together, and that's the hard part today, the irritating part. Okay. So how do you want to do that? Two at a time. Okay, 2 at a time. Pick 2. So we could multiply these 2 together. And x squared, the outside is 4x. The inside is negative 1x, which gives me 3x. And last times last is negative 4. Can I do that? Is that okay to skip that step? Do it in my head?
Yes.
Yeah? Okay, good. Because I can't do that in Algebra 2.
Why? That's what we're in.
They don't. You guys are in honors Algebra 2.
Oh, I thought you were.
Okay. All right. And then for this one, I prefer the box, but if you want to, the box method here. Have I showed you this?
Yes.
I love the box. This is the multiplication box, right? We've done it before. You could just distribute if you want to, but I really like the box for how neat and organized everything looks. X squared times x cubed. 3x times x, negative 4 times x squared times negative 5. Oh, negative 5x squared, very good. 3x times negative 5. And negative 4 times negative 5, 20. And so then I can add up my diagonals here. I've got a positive x cubed, negative 5x squared, and positive 3x squared makes negative 2x squared. Negative 15x and negative 4x makes plus the 20. And there we go. Oh, thank you. There we go. 20, not 2. All right, now that's not too bad. Of course, those are all real.
Oh.
Oh.
I didn't even see that one.
Oh, yeah, those were all real zeros.
Shoot.
Okay.
Oh, shit.
So, they've given us a few other zeros. Letter B. So here's I know x equals 3. And I know x equals negative 3. And they've also told me that x equals positive 2i. That's kind of weird. So, but wait a minute, positive 2i. Do imaginary solutions ever come one at a time? No, they're trying to fool you. Imaginary solutions come from equations like x squared equals negative 4, right? And if we wanted to solve for x, yeah, so if you were to solve for x, you get plus or minus 2i, right? Okay, and so complex solutions always come in conjugate pairs. That's very important. They always come in conjugate pairs. So this book, this is not from your book, but this is from our other book. Yeah, there was a missing imaginary solution. Not only is it positive 2i, but it must also have negative 2i. Okay. All right. So there aren't just 3 solutions. There are 4 solutions, which means we should have an x to the 4th polynomial when we're done. Okay. So these are all the zeros. So x equals 3 came from what bubble?
X minus 3.
Good. X equals negative 3 came from?
X plus 3.
Okay. X equals 2i came from?
X is second plus 2.
No. X minus 2i. And here x equals negative 2i came from?
Oh, plus 2.
X plus 2. Yeah, so it works the same. But I'm going to say when we're multiplying these things out, you want to look for patterns. So here we have a nice little pattern, meaning that's the sum and difference pattern, right?
Yes.
Do we have that same pattern here?
Yes.
Sum and difference pattern. That's really, really helpful. So anytime you have a pattern, you're going to want to multiply those together first. So what is x minus 3 times x plus 3? X squared minus 9, right? Okay. The outside and the inside cancel out. Okay. Let's work through this one, just this once. Or no, let's not. Let's not. Are the outside and the inside going to cancel out here?
Yes.
Yes, they will. The outside is positive 2ix and the inside is negative 2ix. Will they cancel out?
Yeah.
Yes, okay. So First times first is x squared. Last times last would be negative 4i squared. What is I squared?
Negative
Oh.
1.
Negative 1. Very good. So remember, I squared is really negative 1. So what does that change into?
X squared plus 4.
X squared plus 4. Oh, interesting. Okay. And then can we multiply these together? All right. First times first is x to the 4th. The outside is 4x squared. And then minus 9x squared minus 36. So we get x to the 4th minus 5x squared minus 36 for our function. Okay.
Oh, right.
You did it a different way. How many zeros are you going to see if you check this on your calculator? 2. You're only going to see 2. Why are you only going to see 2? Yeah, these are 2 real solutions, and then we have 2 imaginary solutions. So you'll only see it cross the axis 2 times. Okay? So yeah, that is kind of interesting. Okay? Question on that? Because now they get real interesting.
Oh boy.
This is it, yeah. All right. They're telling me that x equals I. Is that the only one? No, because they always come in conjugate pairs. It should be plus or minus I. So there's also x equals negative I. All right. So then I also have this solution. X equals 1 minus 3i. Is that the only one?
No.
What else do you have?
Plus 3.
1 plus 3i. Okay, so remember, they always come in conjugate pairs, plus or minus in front of that I term. So, writing that out, if I had the solution x equals I, what bubble did it come from? Good. And this one would be x plus I. Okay, careful. What about these?
Oh. Okay, so it'd be x plus 1 minus 3i.
Nope.
Bro. Oh, I meant the opposite of that. X minus 1 plus 3i.
Ah, very good. And then this one?
The one I said for her.
Okay, the other one you said, got it. So again, we'd have to move the 1, so that becomes negative, and then we'd have to subtract the 3i, so that also becomes negative. Okay. All right, this is really interesting. So this lesson I just stole from Algebra 2 because we just did this like last week. But they didn't get this question because this is pre-calc. All right, see how it works? Okay. So my pre-calc kids get a question like this one. All right. I expect you guys to do it all. All right. I know, right? Okay, so let's talk about this. So I got the sum and difference pattern thing going on here. That's kind of nice. Which means the outside and the inside, the rainbow cancels out. I'm just left with first times first is x to the 2nd. And last times last is negative I squared. Which becomes x squared plus 1. Very good. Why does it become plus 1?
Because the I squared equals negative 1.
I squared equals negative 1. So this is minus a negative 1, which becomes plus 1. Okay, very, very good. Now, this is also the sum and difference pattern. It just looks kind of crazy. Let me show you. They both have this first term, x minus 1. Plus and minus the 3i. It's still the same pattern, the sum and difference pattern. the outside and the inside will cancel out. I need to assess your faces. You're doubtful, right? Okay. So A plus B times A minus B is the sum and difference pattern. And you know, because that looks like this, right? Okay. But the A could be anything. So could the B. This whole thing represents the A. Okay? Kind of crazy. All right? This is always going to be A squared minus B squared every single time. No matter what the A is and no matter what the B is. Okay? This is where we say you take a step back and just pay attention to the fact that it's something plus 3i and something minus 3i. Okay? So let's do this. First times first. Oh, careful. X minus 1 quantity squared. Okay? Just like A is being squared. It's whatever that first thing is squared. All right? And then last times last is going to be negative. What's 3i times 3i? 9i squared, which will turn to positive 9. I'm going to do that in a minute. This is the hard part. This is x minus 1 quantity squared. What do you have to do for that? Yeah, distributing it out. Yeah, it's x minus 1 times x minus 1, which is x squared minus 2x plus 1. Good. And the negative 9i squared turns into positive 9. So we have x squared plus 1, and you're going to combine your like terms. So we get x squared minus 2x plus 10. I'm not done yet. Okay. Now I got to multiply these two together. So I'm going to do my lovely box. X squared plus 1. X squared times x squared. X to the fourth. Negative 2x times x squared. And then 10 times x squared is 10x squared. And then all this times 1 is just x squared minus 2x plus 10 again. Which gives me x to the fourth. Oh, things aren't really lining up like they normally, so I gotta be a little careful. Minus 2x cubed. I have an x squared and a 10x, which gives me 11x squared. Yeah. Yeah. Combine like terms. Yes. Not too many in this one. All right. So this is very tricky. Be careful with that. That's just stepping back and looking at overall patterns. It's still the sum and difference pattern. It's just that the first thing's a little bit weird. Okay. All right. Do you have other questions for me? No? Okay.
Wait, what's degree? What is degree? Yeah, what is degree?
What does degree mean?
Yeah.
Oh, have I not used that word before? The degree is the highest power of x. So this is a fourth degree polynomial. So the degree is whatever the highest power is. Yeah. Yeah. Oh, you guys are reading the directions. Oh. Okay.
You're not degree or x minus 1 times.
So again, I could. So the question was, do you not find x minus 1 times 3i? So if I wanted to do the outer product, it would be negative 3I times x minus 1. The inner product would be positive 3I times x minus 1. And what are those going to do?
Oh,
Cancel out. Yeah, so we don't need to bother with them. Yeah. All right. You can work on class practice 78. Ladies and gentlemen, please mind your headings on your paper. You should have your